morning, Shawkeynet kids. We are starting an experiment today. It is called the Melting Mint Mystery. We're going to figure out which takes longer to dissolve, regular mints or sugar-free mints. And to start, I have two kinds of mints here. I have red mints and green mints. Now, one of them is sugar-free and one of them is regular. The kids do not know which is which. So I'm going to pass these out randomly. And then we're going to start the experiment. So I'm going to pause you right now. Okay, so the purpose of this activity is not just to eat mints. It's to go through an actual experiment. And so you're going to do it for science fair. So we're going to run through the experiment, and we're also going to do the science board. Now, I've already made the science board. I made this one. I kind of like it. I think it's kind of cute. So I use it year after year. But we're going to run through each step. What's the first step of an experiment? We went over this yesterday. Everybody? You have to ask the question. And our question is, what type of Lifesaver wintergreen mint takes longer to dissolve, regular or sugar-free? Okay? What are the two possible hypotheses for this experiment? What's one? Gwen?
The sugar-free one will dissolve quicker.
The sugar-free will dissolve quicker, or Ben?
The regular one will dissolve.
The regular dissolve. Let's see what and I'm going to use, this is from a class of years ago. Let's see what they said. Actually, this was my hypothesis. I thought that the sugar-free mints will last longer because they have fewer natural chemicals in them. That was my idea, and I thought the science part, they have fewer natural chemicals in them. So I thought sugar-free mints would last longer. Okay? That was my hypothesis. Now, I want your hypothesis. How many of you think that the regular ones are going to last longer? How many think the sugar-free? Okay, I hope I didn't influence you with my hypothesis there. Okay. Now, the next thing we have to do is come up with the list of materials for this project. So I want you guys at home to think about it, and then we're going to talk about it, and I'll show you what the actual materials are. Okay, so the students came up with a few things. Hopefully you figured out what we might need. And for this experiment, we need 2 classes of 6th graders because actually, no, back then I had so many kids that we compared one whole class to another class. This time we're just going to do the comparison in this room. You need regular wintergreen savers, sugar-free savers, a computer for tallying, which we may not need this time, an online stopwatch, a small piece of paper for each student, because you're going to have to write down how long it took for yours to melt, and a pencil for each student. So we're going to stop while we get that equipment. All right, so one thing I want you to notice as we go is that this is an example of how an experiment might be set up. So we have our headings that are standing out, right, a nice title. But now we have a procedure. You are going to be the ones that are going to dissolve them in your mouths. So our procedure is going to have to be as controlling as possible. It's hard to control for everything. So how do you think we should do this? How do you think we should do it? Chloe? Yes, Declan?
Maybe one, like, all the people with green mints, the green line mints, should take those ones first. Then the red people go.
Okay, so you're thinking we should do it in order, yes?
Right when I dissolve, do we tell people?
Say that again, I can't hear you.
Right when I dissolve, do we just what do we do?
Okay, wait till it's dissolved and then tell. Okay, the hard thing is there are some rules. Everybody sucks on things differently, right? Some people bite, some people chew, some people put it around their mouths. So we need to come up with a standard procedure. And I'll just jump ahead and show you what we came up with last time. So, as we know, we go question, hypothesis, materials. The next step is procedure. 1, I will randomly decide which half of the students have regular mints and which half have sugar-free. Well, you guys have already picked them up randomly. I'll pass out 1 mint to each student, have them unwrap them, which you've already unwrapped them. That's great. 3, I'll display the clock on the screen and set it for 0 seconds. I'll do that in a moment. 4, I will explain to students that they must follow these instructions. So once I say put it in your mouth, you have to keep it moving in your mouth all the time. You can't let it sit on your tongue. You have to keep it moving the whole time. Okay, that's rule 1. Number 2, you cannot swallow the mint or bite the mint until it is completely dissolved. You cannot swallow it or bite it. You have to keep sucking on it the whole time and moving it around your mouth. Number 3, you have to try to keep your mouth closed if you can. And above all, you cannot talk. You cannot talk during this time because it'll force you to stop moving that around. Okay, any questions about how to do it?
Like, how long did it usually do?
I'm not going to tell you that. That will prejudice your answers. Then I will press the start button on the clock, and at the same time I do that, you're going to put the mints in your mouth and you're going to start trying to dissolve them. As soon as yours is gone, look at the time on the clock, and I'm going to show you that clock right now.
And put it on
This is our clock right here, seconds and minutes. Record it on your paper, okay? And that's how it's going to work. Okay, I'm going to stop. Actually, I will leave the camera on while I start it. Are you guys ready?
Yes.
Okay, when I say go, I'll start the clock and you
Oh man.
Ready, steady, go. Okay, as you guys at home can see, the clock is going. Whoops. Okay, I'm going to pause now. So in this experiment, it's really hard to control for how the kids dissolve their mint in their mouth. But they're all doing their best. They're all constantly moving it right now. I see their chins are moving. And so far, nobody has recorded anything, and we are up to 2.5 minutes. So it's going to take a little while yet. Okay, everyone has finished now. What they're doing is they are recording their times, but they have to convert their minutes and seconds to seconds. So if you look right here, you'll see that they're recording their times on the board after converting them. Okay, and then we'll discuss the results in just a minute. Okay, so the calculations have been done. And we have discovered that, and we took the averages because averages are very important. You could list all these numbers there, but what is that going to tell you? So the average of the regular is 397 seconds. Please put your desk down. And the average of the sugar-free is 307 seconds. Which took longer to dissolve, everybody?
Regular.
Did our results support our hypothesis?
Yes.
Yes.
My hypothesis was that the sugar-free mints will last longer. Which lasted longer? The regular. Every single year I do this experiment, and I have done it now for about 10 years, I get the same results. The regular lasts longer. So my mind was, the first time I did this, I go, why? I did not know why. I had to find out. So let's look at some past results from other schools. Now, when I was teaching at St. Francis, I had way more kids. I had 2 big kids. So I had 27 in one class, and I had 25 in the other class, all right? And then they each did their own thing. But overall, you got the same results. The regular, which is blue, took longer than the sugar-free, which is green, in both classes. But what I want to show you is how I displayed my results. What do you guys notice? What did I do to display my results? What exactly did I display? Anna, what did I do?
You did a line graph.
Okay, this is actually a column graph. All right? I did column graphs with averages. What's this here? Ben, do you know?
Charts for the amount of time it took.
Charts of the amount of time. What do I call that data if it's straight off your measurements? What kind of data is that? Come on, Bruce.
Raw data.
Raw data. So this is my raw data right here. Now you guys wrote it on by hand, but then I collected the raw data from the students and I made a chart. So I put all the raw data there so people could see it. But if a person comes up here, they really wouldn't understand by looking what it is. So I found the mean and I transferred that mean to a chart so you can see the average. Can you see clearly which lasted longer? Yes, you want that clearly done. So that's how I displayed my results. What is the final part of an experiment, everybody? It begins with a C. 1, 2, 3. Conclusion. The 4 questions of a conclusion. Let's try to say them together. Did my results support my hypothesis? Why or why not? What did I learn? What would I change? So I'm going to read this to you because I am. It's right here. So you can't see this from here, so I'll read it to you. The results of my experiment did not support my hypothesis. The regular mints, on average, lasted longer than sugar-free mints. Why this occurred is difficult to explain. I feel confident it has something to do with the chemical makeup of the mints, since the ingredients in the two mints are completely different. The regular Lifesavers contain sugar, corn syrup, artificial flavor, and stearic acid. The sugar-free Lifesavers contain sorbitol, magnesium stearate, artificial flavor, and aspartame.
Wait,
Right? Completely different ingredients. So even after doing research about the results, though, I was not satisfied with my answers. So I consulted other scientists to get their input. I tried to find out what not. So I went to some scientists, right? And I'm married to one, so I started with Mr. Lemke. Dr. Lemke, though, didn't know. But he felt that it did have something to do with chemistry. He said that the speed of the mints dissolving might be related to the strength of chemical bonds or how the chemicals react to water. Then I went to Sally Atkins Burnett, who she's a scientist, who said that corn syrup in regular mints is hard to dissolve, and that sorbitol for sugar-free mints is a quick-to-dissolve substance. The other scientists I asked were stumped, so I had to keep asking. That's as far as I got. There were two things I learned from doing this. First of all, it's nearly impossible to get people to suck on mints the same way. That's one thing I learned. If you look at these numbers, we've got someone with 459 and somebody with 214. So clearly there was something different about those.
214.
Secondly, despite my instructions, some students were biting, some students had their mouths open. This was in my first class, which caused reduction in saliva. Some people hardly moved their mints around, and some students could not avoid talking. That was not you guys. You actually were very quiet. In my first class, yep. What question have I not answered yet? What would I change? Secondly, the difference in average time between 6A and 6B was substantial. There are many possible reasons for this. Time of day, level of hunger, because I did it in 2 different days with 2 different times of day. If I were to repeat this investigation, I would do it with many more classes, perform it at the same time of day, and to try it with fruit-flavored Lifesavers. Okay? So that's what I would do differently. Now let's look at the board, everybody. What makes this a good oh, by the way, there was a big picture here of the whole class, which somehow fell off. What makes this a good display board? Based on what you learned yesterday, Peyton.
You have like background, like the lettuce pot.
Okay, so I have backing. In fact, I have double backing. You have green and blue. Green and blue. Declan?
I can see it from 2 feet away.
You can read many of these things in titles from 2 feet away. Good. So, Chloe.
You have images?
I'm sorry?
You have images?
I have images. I have pictures on here. These are actually kids with the mints in their face, the mints in their mouths. Gwen?
The color coordination is immaculate.
She likes the color coordination. What did I match the colors to? Can anyone tell? Where did I get the color ideas from? Anna, do you know?
They're on the Lifesaver.
From the Lifesaver packages, right. The Lifesaver packages were that green and blue, so that's why I chose that. What else?
Oh, you have a really big, eye-catching title.
Okay, my title. So I made them like circles, like mints, and I had fun with that, I have to say. That was kind of fun. And what else was on there that makes it stand out?
The reason you have every single thing on there, question, hypothesis.
Okay, I've got all the parts, nothing's missing. And also I used little reinforcements to make them look like little mints. Okay? Is that what you're going to say, Ava? Cruz?
And you don't have to go looking for. Yeah, you don't have to go looking for the.
Right, you know right where to look.
Yeah.
All right. Chloe?
Can you say suggestions?
Hold back, so I would love a suggestion. Ben?
You have graphs and charts.
Graphs and charts, which are critical. What's your suggestion?
Like get actual mints and put it around the board or something.
Oh, okay. Take some actual mints and glue them up. That's a great idea. I love that. That would be another step up. Okay, so guys at home, that's how you do an experiment. And yours could look just like this or probably better if you take the time. We went through everything today to show you how it is done. Okay? The assignment will tell you what you have to do to follow up for this.